Okay, I'm going to give an example of using a method of finding whether you have an outlier or not. And so we learned a little bit about outliers. These are extraordinary data that are separated from the main body of the data. So if we get points that don't seem to fall in the range of most of the other data points, we consider these outliers. And we can actually check to see if something is an outlier or not. And it uses this simple formula for the upper boundary and the lower boundary. And what you need to do is to take the upper quartile, which is Q3, and whatever value you have for that is you add 1.5 times the interquartile range. So the interquartile range, that's what we want to do here. All right, so interquartile range. And then if you want to find the lower boundary for the box and whisker plot, then it's going to be Q1 in this case. And actually you're going to subtract, so you want to go to the left of Q1 of 1.5 times the interquartile range here. Okay, and I'll show you an example of what we're going to do to just check and see if we have any outliers. So we've been given this data, and I put the data in order so we can find the median, the Q1, Q3. And of course, if you use your calculator and run one var stats, you can find all this data here. So I've done that. Remember, stat, calc, one var stats, and I have my list already in L1, and it gives me these values. So just so I can show you, here's my list with all my data values in it, and I run one var stat. All right, so I can write down the values that I find here. So if I do that, I'm just going to move this over here. I have Q1 is equal to, in this case, it's 6.5. You have Q3, which is equal to 10. And your median value is equal to 8 in this case. Okay. But we can do all this by hand as well. So if you notice that we have 20 points here, I can draw a box that separates the stuff perfectly in two. So the first 10 points are here, and the second 10 points are here, so that you can see actually these two middle points, 8 and 8, are shared amongst each other. So that gives our median of 8. So normally we would have to add these two and divide by 2, but since it's the same number, we get a median of 8. All right. If we want to find the quartiles by hand, it's easy. We want to find the 25% of the data and then 75% of the data. So if you go 0.25 times the number of data points, and there's 20, you're going to get 5. So 5 points here is equivalent to 25% of the data points. So if I pull 5 together here, that's your first 25% of the data. And then if I make another box, this is your second 25% of the data. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So there we go. I can see from my median, the two middle points was actually these two 8s here, but it doesn't make a difference. We still get a median of 8. So the two middle points are actually these two 8s here. Okay, I was off by 1. I miscounted, but that's okay. It doesn't change our answer. So we have 25% of the data here, 25% of the data in this second box, 25% of the data in this third box, and 25% of the data in this fourth box. So if you want to find Q1, you want to find the 25% value. But as you can see in here, the 25% value is actually right in between 6 and 7, because you have 5 here and 5 here. And we were hoping for another value in between that really fits the 25% data value we're looking for. So when this occurs, it's no problem. we just do like we did in the median. We take these 2 points that are shared at the 25% level, we add those together and divide by 2, and as you can see, we get 6.5, which is good, the same as our Q1. And then we're going to do the same thing at the upper level at the 75% value. And as you can see, it's shared 10 and 10. So if we add those two together and divide by 2, you will see that our Q3 is also 10. Okay, so if we want to find our interquartile range, which we need here for our values here for our formula, we want to do Q3, which is 10, minus Q1, which is 6.5. And that gives us 10 minus 6, 4, 3.5. So our interquartile range is 3.5, and we're going to use that in this formula above. So if we want an upper boundary, so let's start building our box and whisker plot. So if I have a value, just let me figure this out here. I'm going to draw a line here. And we want to figure out our lower boundary and our upper boundary, which shows us where we can draw our ends of our whiskers. Okay. So if we do that, we can use our formula. So our formula here for the lower boundary is the lower quartile. So I'm just going to put here lower boundary, LB, is equal to our lower quartile, which is 6.5, plus 1.5 times the interquartile range, which is 3.5. And then we can use and try and find our upper boundary here. And it's going to be our upper quartile, which is Q3, plus 1.5 times, in this case, our interquartile range again, which is 3.5. And if you use your calculator in this case, you will find that your upper bound is 15.25, and you'll find that your lower bound is 1.25. So sometimes what they'll do is they'll give you a question and they'll ask you if there's any outliers, and you'll have to figure out based upon this if any of the points are past these points. So if our lower bound consists of 1.25, do we have any values that is lower than 1.25? And if you look, we actually do here. We have a value of 1, which is less than 1.25. And then we ask yourself, is there any values higher than 15.25? And there's a value of 16. So both of these values tell us that we have some outliers here. So if we start to create our box and whisker plot, I draw a plot like so. And normally the IB gives you a graph with all the variable numbers on it. And for now, I'm going to create the box with my whiskers. And then I'm going to add in our Q1, Q3, our lower boundary, and our upper boundary. So we normally have a box that looks kind of like this. Then we have a line here. And now let's put in our values. So we know that the Q3 in this case was 10. Our Q1 was 6.5. We have the median, which is 8. And now what we figured out is that we have 2 points, which is 1 and 16. And these are our outliers. So way over at 1, we have a point here which we consider an outlier. So it is no longer part of our box and whisker plot. And the other point that we found out, which is an outlier, is 16. So that was also beyond our upper boundary. So that point is also outside our box and whisker plot. So that must tell us that the minimum value now, we don't count this one. Our next value is 3. So here we have our value of 3. And then the max value is no longer 16, but it is 14. So here I have a value of 14. So just to recap, we're given some data, and it could be that some of these points are outliers. So what we do is we find our Q1 or Q3, our interquartile range. We use this formula here, which allows us to figure out if there are values that are beyond our upper bound and our lower bound. And so we found the lower bound is 1.25. So anything lower than that is considered an outlier. And we found out that our upper bound was 15.25. So any values higher than that is an outlier, which is 1 and 16. As soon as we found out that those outliers exist, we eliminate them from our box and whisker plot, and we readjust our minimum, which is 3, and our maximum, which is 14. All right, so that's what we have for outliers and how to find out outliers using this method and these formulas. Now, these formulas are not in the book, so you have to memorize these two here to check for outliers.